Welcome all. Data engineering subject we are learning, and in the previous video we had covered serving data for analytics, machine learning, general considerations for data analytics from unit 5. In today's video we'll be covering machine learning, ways to serve data for analytics and ML. So these are the two topics in focus, including the analytics part. So first what we'll do is we'll go through quickly what we have covered in the previous video by referring few of the keywords. Then we'll move to the next part. So this was our chapter, serving data for analytics, and this word serving is one of the stages of data engineering life cycle, starting with generation till serving. So generation has happened, storage of data has happened, ingestion transformation has happened. Now that data needs to be served. That data needs to be served to whom? To analytics, to machine learning, to reverse ETL. This chapter is all about this aspect of serving data to analytics, machine learning, reverse ETL. Now, but before serving the data, what we have seen the general considerations in the previous video, like trust and how to gain trust through data validation, through data observability, through SLAs, SLOs. Then we saw use case and the user, then the data product, then self-service or not self-service, which is an aspirational aspect that we covered. We then covered data definition and logic and data mesh. So the next in continuation is the analytics part from the syllabus. So just to confirm, unit 5 we covered serving data for analytics, machine learning, general consideration for serving data. Now in continuation, analytics part we'll be taking. So what is analytics? Discovering, exploring, identifying insights, new patterns. This is all analytics, and this is the first use case of data serving. Okay, so what things analytics part does? Statistical methods it will use. It does reporting. It uses BI tools. But before serving the data for analytics, the use case needs to be understood, like whether it is for historical data, whether it needs immediate alerts, automatic notification of anomalies or errors or frauds. So are they consuming the real-time dashboards on a mobile app? So these use cases will highlight the differences between business analytics, operational analytics, embedded analytics. Now, when we speak about business analytics, it refers historical and current data. And when we speak about business analytics, we are basically speaking about dashboards, reports, ad hoc analysis. And when we are speaking about a dashboard, so we are speaking about a lot of charts, lot of heat maps, lot of summary statistics, and so on and so forth. Now, the dashboards are created with the help of analysts, and the tools which are commonly used for creating dashboards can be Power BI, Tableau, Looker, Sisense, Apache Superset Preset, and so on and so forth. Now, it may happen that the analyst may perform sometimes ad hoc analysis whenever, depending on the dashboard, he is asked to dig further, he has to get further insights. So such request will be called as an ad hoc request, and the resultant will be an ad hoc analysis, and that resultant will also be a dashboard. But what will be the tools? Similar tools along with Excel, Python, R-based notebooks, SQL queries, and so on. Whenever we are speaking about business analytics, the data will be served in batch mode. from a data warehouse or from a data lake. The frequency may vary. Now, the first one was business analytics, the second one is operational analytics. How to differentiate between them? Operational analytics is more into immediate action, while business analytics is more into actionable insights. So one major factor which differentiate operational analytics and business analytics is the time. So business analytics takes a longer view, while operational analytics takes a real-time update kind of thing. Say for example, there is a real-time application monitoring system, because the software team always wants to know in time any issue has arise, they want to be notified immediately. There can be a dashboard with a lot of metrics like request per second, database IO, and so on. Coming to the third analytics, that is the embedded analytics, which is uh, analytics dashboards embedded within an application. Say for example, you have thermostat, okay? So, and it's a smart thermostat which has a mobile application. So that shows temperature in real time and up-to-date data power consumption metrics. So what will happen is, with this, the user can create a better energy efficient heating or cooling schedule. Now, the first layer was analytics, where the data will be served. The second area where the data will be served is machine learning. And we know that machine learning, data science, data engineering, machine learning engineering, the boundaries between them have become very fuzzy, right? So, and they vary organization to organization. In some organization, ML engineers have a specific task related to ML application data processing, while in some others, data engineers may play the role. In the first example, data engineers may be handling other data processing activities. In some cases, data engineers may also use ML specific tasks, such as featureization of data and so on. Now, when we are serving data to ML as a data engineer, we should also know a bit about machine learning, like what are supervised, unsupervised learning, and different types of learnings. What are the different algorithms like classifications, regressions, logistic regressions, support vector machines. What is time series? What is time series forecasting? What is not? When to use auto ML? What is data wrangling? So what are the different types of data, how to encode them, what is the difference between batch and online, where the data life cycles of data and ML intersect, when to use a GPU, when to use a CPU, when to use a cluster, when to use an edge, when to use which kind of hardware, what is the difference between batch and streaming data, what are data cascades, are the results in real time or in batch, when to use structured data, when to use unstructured data, when to use cluster tabular, when to use images. So all those aspects related to machine learning, as a data engineer, we should learn. Now, how do I serve the data for analytics and ML both? Okay, so if you remember the diagram of the data engineering life cycle, we are serving data, and serving is the last stage, fifth stage of the data engineering life cycle, and we are serving the data to analytics, to machine learning, and for reverse ETL. So the question is, what are the different ways of serving data for analytics and ML? One way is file exchange. So maybe we are exchanging a text file, which is an unstructured data, maybe an invoice, which is a structured data, maybe an image, which is unstructured data. So while serving this, you should also understand the use case. You should also understand the data handling processes of the data consumer, the size and number of individual files, who is accessing the file, what are the different types of data. Say for example, the simplest way of exchange file serving is through email. I may send an Excel file, right? But I know that there may be multiple versions form. We don't know which one is the consistent, which one is the coherent. So if I really want that, so I may use some kind of data sharing application, or tools like Google Docs or Microsoft 365 will do that. This was the first way of serving the data through file exchange. The second way is through databases. And when we are speaking about from the data engineering perspective, we are speaking about OLAP data. When we say OLAP data, we are speaking about data warehouses and data lakes. Okay. So, and how do I serve the data? I'll be querying the database, and the resultant will be consumed by the use case. Is it not? So it has lot of benefits because of the databases will be offering some structure, some schema, some fine-grained control, administration, better performance, concurrency. So all those aspects are there. Now you have different business intelligence tools also, right? So they may share the data processing workload with a source database. Uh, you also have different kinds of example. For example, Tabla is there. The Tabla server running an initial query to pull the data, and the slicing and dicing will be running directly on the server from the local data copy. But let us say you are using a tool called as Looker. So it has something called as a query push down. So here data processing logic is encoded in LookML language. It's a specialized language, and this is combined with dynamic user input to generate SQL queries, which are run against the source data set. Is it not? A data scientist may be connecting to a database, he may be extracting the data, he may be performing feature engineering, he may be performing selection, he may convert the data set. These converted data sets will be fed into the machine learning model. The offline model is trained, and then it will be producing the predictive results. Now you have streaming systems, you have query federations, and we know that query federation is what? It will be pulling data from multiple sources such as data lakes, RDBMS, data warehouses. Federation has become quite popular because of distributed query virtualization engines. You have examples of OSS options like Trino and Pesto and Starburst. Coming to data sharing, it more turns into a security and access control kind of a problem statement. You also have semantic and metric layers, which basically are about maintaining and computing business logic. Uh, they may build transformation queries. The examples can be Looker, data build tool, DBT, and so on. So you'll be serving data in notebooks also, and one of the popular notebooks is Jupyter Notebook, and Jupyter stands for Julia, Python, and R, right? The third way of serving the data is reverse ETL. And what is the standard example of reverse ETL? A data engineer may be pulling customers and order data from a CRM, and he may be storing it in a data warehouse. This data on the data warehouse may be trained as a lead scoring model whose results are again fed back to the data warehouse. This fedback data will be used by the company sales team for better lead generation. So this can be an example of that. So, while serving data, a data engineer may be working with different stakeholders like data analysts, data scientists, machine learning operations, machine learning engineers, uh, different non-technical stakeholders may like managers and executives also. So this was what our focus of discussion, Unit 5. And we tried to cover today analytics, machine learning, ways to serve data for analytics and machine learning. The next topic in the next video may be the future of data engineering.